Hello everyone, welcome back to my YouTube channel. Today we are going to look at integration by parts. If you are new to my channel, please do well to subscribe. And if you are a regular listener, a regular visitor, a regular person on my channel, you are welcome. Thank you for subscribing. Without wasting much of your time, let's go into the video. All right. So like I said before, we're going to look at integration by parts. So what I'm going to do is I'm going to introduce the formula for solving integration by parts. All right. Integration by parts. All right. So now, we just finished differentiation to the best of our knowledge. I mean, the most important part of differentiation, we have finished it. Our differentiation span across um, direct differentiation, differentiation by product and quotient rule, and then differentiation by chain rule. Okay. And then we try to incorporate uh, trigonometry, uh, trigonometric functions in our differentiation. And I also made it open that if you have any question, any problem that is in line with what we have discussed in the previous videos, you can bring it on and I'll be glad to assist you to help you solve them. All right, so we recall recall that in product rule, if y is equal to u v, where u and v are function of x, are functions of x, then dy dx is equal to u dv dx plus v du dx. So right here, we can multiply both sides. We want to um we want to derive the general formula for solving integration by parts, so that when we see a question, we should know what method we should use to solve it. All right. So here we can multiply both sides by dx. If we multiply both sides by dx, we will have that dx bracket dy dx equal to dx bracket u dv dx plus v du dx. So dx we take care of the x, we have that the y, we will now have that the y is equal to v du plus u dv. So what we are going to do here is to make, we're going to integrate both sides. Integrate both sides. So, we have that the integral of 1 dy is equal to the integral of v du plus the integral of u dv. Now, if you integrate 1 with respect to y, 1 is like y to the power 0. So if you integrate y to the power 0 with respect to y, you have y. Remember, 0 plus 1 over 0 plus 1 equal to this. Now, remember that our y is equal to uv. So our y is uv. So we're going to have uv equal to integral of v du plus the integral of u dv. So simply, the integration by parts will be, if we make this the subject of the formula, we take this over to the other side of the equation, we have that the integral of v du is equal to uv minus the integral of u dv. So this is the formula, this is the final formula we will always use anytime we are solving the integration by parts. All right, without wasting much of your time, let's take one example so we know how we can apply this formula. All right, let's take one example. Let's say example one. Integrate x sine x. Okay, solution. You say let y be equal to x sine x. Okay, so the integral of x integral of y dx will be equal to integral of x sine x dx. So we try to apply our formula integral of v du equal to uv minus the integral of u dv. So from this, our v is x, then our du, so this is sine x, okay? So our du is sine x dx. So v is equal to x. Meanwhile, our du is equal to sine x dx. All right. So looking at the other side of the formula, we already have our v, and from du we can get our u, and from v we can get our dv. All right, so let's get our dv. So dv dx, that means we are differentiating. We differentiate x, we'll have 1. So this implies that dv is equal to dx. Then in this, for us to find u, we're going to integrate this. Okay. So this is like having 1 du. Okay. So we integrate both sides of this. We have the integral of sine x dx. If you integrate 1, let me do this one last time. If you integrate 1, you have u. This is like u to the power 0. So you have u to the power 0 plus 1 over 0 plus 1. So this will give you u equal to, if you integrate sine x, you're going to have minus cos x. If you watch my previous videos, you would see where I showed you draw a table where you can what you will get when you integrate sine x and cos x. All right, so now we have everything we need, so we can plug it in here. So we come back, we now have that the integral, which is sine x, which is x sine dx, x sine dx, sine x dx, I mean, okay, is equal to, what's our u? Our u is minus. So I'm going to bring in x minus x cos x. Okay. Then minus, what's your u again? Your u is coming in with minus. So it will interfere with this, it turns plus. It will interfere with this, and it will turn plus. So we now have the integral of our u dv. And our dv is what? Dx. So we have integral of cos x dx. So right here, we have one last integration to do. So this is equal to minus x cos x. If you integrate this, you're going to have plus sine x. So we can now add C, the constant of integration. So with this, we are done solving this problem. Okay, so we're going to take just one example today so that we don't make the video too long. In our next class, we're going to take 2 more examples. All right, thank you for joining me today. Like I said before, if you are new, do well to subscribe. And if you are old, you are welcome. Welcome. Thank you for subscribing. See you in my next video. Bye-bye.